Now we have a session today with Eunsuk, who is from Korea, and so we will have the presentation of the Korean Association of Logic. And the chair today is Jui-Lin Lee, who is a member of the Editorial Board of Studies in Universal Logic. So I give the floor to you, Jui-Lin. Thanks.
Okay. So welcome to the session of Logical University's webinar. And today, first, we will have an introduction to Korean Association for Logic. So we are happy to have the secretary of the association, Professor Lee-Ho Park, to tell us much more about Korean Association for Logic. And before that, let me introduce to all of you Professor Lee-Ho Park. Lee-Ho is a philosopher. Currently, he is an associate professor in the Department of Philosophy at the Jeonbuk National University in South Korea. His areas of specialization are formal epistemology and philosophy of science. And also his areas of competence includes logic, metaphysics, epistemology, and philosophical logic. So Lee-Ho, please take over this.
Yes. Can I share my display? It's okay?
Yes, it's okay.
Yeah. Hi. First of all, thank you, Rie, and thank you for your kind introduction for me. Anyway, my name is Lee-Ho Park. I'm working at Jeonbuk National University in South Korea, as is introduced. As posted, I am also a member of Korea Association for Logic, namely the KALE. In particular, I'm the secretary of the association. First of all, it is a great honor to introduce myself and the Korean Association for Logic to these outstanding logicians and philosophers. Moreover, I really thanks to Professor Beju for providing me an opportunity to give a talk in this Logica Universalis webinar. It is introduced that I am a philosopher. My research mainly focuses on inductive logic, Bayesian epistemology, Bayesian philosophy of science, etc. In this talk, I will introduce the Korean Association for Logic. In particular, I will explain some main activities of the society, of the association. The KALE was founded in 1976. The KALE has currently about 50 or 60 members whose research topics are various. For example, logicians, philosophers, mathematicians, computer scientists, etc. belong to the KALE. Almost members of the KALE focus their research on logic and analytic philosophy. Especially the members are working on formal and informal logic, symbolic logic, inductive logic, scientific methodology, philosophy of language, etc. And the current president of the KALE is Professor Eunsuk Yang. Eunsuk Yang will give a talk of this introductory talk. Professor Yang is working at the same university as mine, namely he's working at the Jeonbuk National University in South Korea. Professor Yang is one of the leading logicians and philosophers in Korea. In particular, he made some real contribution on non-classical logic system. He published some papers about fuzzy logic, relevance logic, relational semantics, and so on. I think they are all great works contributing on the development of logic in Korea. Of course, there are other outstanding members of Korea Association for Logic. Some information about the KALE and each members is given on the official website Korea, in the website. This is the address of the website. Unfortunately, the website is given in Korean. Sometimes later we will construct an English version of the website. Now, let me introduce the academic activities of the KALE. This association mainly carry out two activities. The firstly, the KALE has been publishing a journal whose title is Korea Journal of Logic. Secondly, the association has been hosting various academic meetings, for example, semi-annual conference and monthly seminar. I will explain these things one by one in as follows. The Korean Association for Logic has been publishing the KJL. The KJL is a peer-reviewed journal. The KJL is published. KAL has published the KJL since 1997. The KJL is published 3 times per year, namely February, June, and October. Until now, the KJL has published 25 volumes and around 250 papers about logic and analytic philosophy. The KJL is indexed in the Korea Citation Index. The Korean Citation Index is issued by Korean government organization. Of course, you can also find the KJL papers in Google Scholar. Some papers in KJL are in Korean, some papers are in English. Nevertheless, all papers include an English abstract, so you can find a rough idea of the papers, and you can, if necessary, attempt to contact the authors. All papers in KJL can be found in 2 ways. First, you can find the papers in official website of the KJL. This is the address of the official website. Second, you can also find the paper in journal and article management system for the KJL. This is the address of the system. The first website is given only in Korean, but the second one is given in Korean and English. You can also submit your excellent paper to KJL. To submit your paper, you should visit journal and article management system for the KJL. In this homepage, you can find an English guideline for the submission to the KJL. The current editor-in-chief of the KJL is Han-Seung Kim, who is working at Kookmin University in Seoul. Our journal is a peer-reviewed journal and typically delivers the first decision within 1 or 2 months. Now let me explain the academic meetings hosted by KAL. There are 2 regular academic meetings that has been hosted by KAL. The first one is semi-annual conference. The second one is monthly seminar. Besides these meetings, the KAL has hosted some irregular meetings. In particular, the association co-hosted several conferences with the other Korean societies. For example, the Korean Society for the Philosophy of Science and the Korean Society for the Analytic Philosophy has co-hosted a conference with the KAL. The semi-annual conference, this conference is held twice per year, winter conference and summer conference. Each conference consists of 4 or 5 speakers who give a talk about various topics related to logic and philosophy. The latest conference was held online in this February. 5 speakers gave their presentation about philosophy of language, mathematical system, and metaphysics, and etc. The monthly meeting. The objective of a monthly meeting is to share the academic trend and members' academic interest. So the KAL's monthly meeting is run flexibly. Some articles about logic and philosophies are often introduced and discussed. or some members often give a talk about current academic trend relevant to logic and philosophy. Recently, we discussed Bayesian epistemology, truth-maker semantic, and the philosophical implication of Gödel's theorem. Besides the aforementioned academic activities, the KAL often carry out some non-profit and non-academic activities. Recently, some committee members of the KAL have taken part in a government-driven project. The government-driven project is the project is intended to develop a high school logic curriculum and write the high school textbook of logic. In doing so, our members and our association strive to enhance the logical capacity of our society. That's all. Thank you for your listening.
Okay. So is there any question?
Well, I would like to thank you very much for your presentation, Elio. It was very interesting. And I didn't know there were so many activities for logic in Korea, so it's good to know. And my question is the following. What are the interaction between this association of logic in Korea and other association of logic in the rest of the world? I mean, let's say to nearby countries like Japan or also anywhere in the world. Do you have some contact? Do you have a lot of people from outside who visit Korea? I have never been yet to Korea, but that's my question.
As far as I know, there are some little connection, Korea association with the other society in other country. But there are some event. There was some event in this day. For example, I think in Chinese association about logic, some co-hosted on couples, right? I think can the Eunsuk Yang can explain this event.
Yeah, just actually we got some kind of seminar with the Chinese part this February. Just this is not the regular one. Just this is some kind of special event. I have some connection with the Chinese guys.
Yes, I think there are a little communication with the other countries in Korea, but you can want it.
Okay.
Oh, Iho, I have a question for you. You are quite correct that your webpage, the webpage for the Korean Association for Logic is actually in Korean language. But anyway, thanks to the help of Google translation, I actually translated into Chinese. So I also got some information about that. But what I found is the journal, the name of the journal is like, what I found is looks like Logic Research. Is that exactly the one you mentioned? The Logic Research, it also starting from 1997. Is that the one, the journal you just mentioned? KJL. What I found, the name of the journal managed by the KALE is the Logic Research. Okay, yes. So is that the one, the journal, the Korean Journal for Logic, is the same one?
There are other Korean. I think there are some other journal for logic in Korea, right?
But I found it from the webpage of your association.
Yes.
So I think probably the same one with maybe it is called but in Korean language by a different name, maybe. I don't know.
Yeah, this is my fault.
No, that's all right.
I should correct my page.
Yeah, I think Korean Journal for Logic is a nice name.
Yeah, I think the official name is Korean Journal. The official name is Korean Journal of Logic.
Okay.
My homepage is
So that's the official name.
corrected.
All right.
Yeah.
So is there any other questions? Okay, so Jean-Yves, maybe we start from the next part, right? Okay, so next I would like to introduce to you our speaker, Professor Eunsuk Yang. So Eunsuk Yang received his PhD in Department of Philosophy from Yonsei University in 1997. And he visited Indiana University, Bloomington, USA in 2001 and 2, and also 2017 till 18. And currently, Eunsuk is a professor of philosophy department at the Gyeongbuk National University in South Korea. His research interests include non-classical logics, in particular, fuzzy logic, substructure logic, reference logic, and algebraic logic. And today, Eunsuk's presentation is about two of his recent papers, which are joint work with J. Michael Dunn. And the title of these two papers are, the first one is Implicational Tonoid Logics, Algebraic and Relational Semantics. And the second one is Implicational Partial Galois Logics, Relational Semantics. And both papers are published in the journal Logical Universalist last year. So let's welcome Eunsuk. Okay, so please do your presentation. Yes.
Okay, thank you so much, Yui, and I especially thank you, Chang Yi. Can I share my presentation? Okay, is that okay to you? Is that okay to everyone?
Yes, it's all right.
Okay, thank you, everyone. I don't want to introduce myself because Lee already introduced me. Thank you so much. I just get the title Implicational Tonoid and Partial Galois Logics. Actually, these are some summarization of the two papers already mentioned. Okay, first of all, I would like to read the dedication written in this paper, because I want to dedicate this paper to the writer Mike Dunn. When I went to Indiana University as my sabbatical visit in 2017, Mike and I had a weekly academic meeting. During meetings, we planned to work together with this subject, and the draft was completed when I came back to Korea in 2018. With several refinements, we finally submitted the manuscript to Logical Universalist in August 2020. Unfortunately, he passed away in April 2021 before I had the good news of its acceptance from Professor Jang-Yves Beju, the editor-in-chief of the Logical Universalist, in September in 2021. As far as I know, he's one of the most warm-hearted and tender people. I will always remember Mike and our happy days. I miss him so much. Okay, the outline is this. I have 7 sections. First, I give some introduction, especially it has abstract background and motivation. From the second end to the 4th sections, this is related to my first paper. I first introduced ITLs, that is Implicational Tonoid Logics, and compared these logics with the equally implicable logics. And then in section 3, I introduced algebraic semantics, more precisely metric semantics and algebraic completeness. In section 4, I introduced relational semantics for ITLs. More precisely, root-minimized semantics and provide soundness and completeness. The sections 5 and 6 are related to my second paper. In section 5, I introduced IPGS, that is the Implicational Partial Galois Logics, as partial Galois extensions of Implicational Tonoid Logics. Similarly, I introduced relational schematics. And finally, in section 7, I give us some concluding remarks. First, abstract there. We combine two classes of generalized logics, one of which is the class of weakly implicative logics introduced by Scintilla, and the other of which is the class of tonoid logics introduced by Dunn. For this, we introduce implicational tonoid logics and their partial Galois extensions. More precisely, first, we define implicational tonoid logics in general, examine their relation to weakly implicative logics, and provide algebraic semantics for the formal logics in sections 2 and 3. Next, we introduce relational semantics called Rutemaya style semantics for finitary implicational tonoid logics in section 4. Finally, we extend this investigation to implicational partial Galois logics. That is, we define some implicational partial Galois logics as special kinds of implicational tonoid logics and provide Rutemaya style semantics for finitary those logics in sections 5 and 6. Okay, then I introduce background. I have two backgrounds. First one is implication and partial order. One important trend in alternative logic is to introduce after logics with more general structures. In this tradition, the logical connective implication is very important in the sense that systems of logics are often distinguished by the properties of their implications. There is some kite I would like to show you. The implication in Lambert calculus, that is the weakest one in this kite. Lambert calculus actually require the associativity as its structural rules. If we add the commutativity, we can get the implication in linear logic. If we further add the scale increasing, then we can get the implication in relevance logic. On the other hand, if we add the lower bounds, then we can get the implication in BCK logic. If we have both of them, then we can get the implication in intuition logic. If we just consider the implication part, then there's no difference between intuition implication and material implication. So this is the most strongest one. And back to the background. These implications all share and list the underlying properties of reflexivity. That is, A implies A is provable. Similarly, transitivity. Because of these two, it forms some kind of pre-ordering. That is, this suggests an abstraction based on pre-ordered sets. If A is an algebra, we want an equivalence relation to be a congruence. Because of congruence, we can give some kind of algebraic semantics. Pre-ordered sets can be regarded as partially ordered sets by defining an equivalence relation. This is a usual one. And second background, abstract algebras and logics based on partially ordered sets, so-called POSES. There are two important trends. The first one is the implicative logics and their generalizations. Rashowa in 1974 introduced implicative logics. These are for logics based on POSES with the greatest element 1 as the sole designated element. Scintilla generalized implicative logics into weakly implicative logics. These are for logics based on the POSES with the operations satisfying congruence, and with D as a designated subset of elements. He introduced these logics in 2006. The other trend is the gaggers and their generalizations. Galois is, the term Galois is a syncronym of generalized Galois logics. These are four logics based on the distributive lattices with operations satisfying abstract Galois connection properties, introduced by Dunn in 1991. After 2 years, he generalized Galois into partial Galois. As you can see, he took the process in place of distributive lattices. The other property is the same. The other properties are the same. So he generalized into process. In the same paper, he further generalized partial Galois into tonoid. As you can see, tonoid requires tonic properties in place of abstract Galois connection properties. The motivation is this: the abstract logics with more general structures mentioned above have been investigated independently. However, we can consider a common area between such logics. So the aim is this: to consider a combination of the two classes of generalized logics, one of which is the class of implicative logics introduced by Scintilla, and the other of which is the class of tonoid logics introduced by Mike Dunn. More precisely, to introduce implicational tonoid logics, ITLs for short, and their partial Galois extensions, IPGLs for short. Here, tonoids algebraically opposite with a set of analytic operations being isotone or antitone on each ith argument. The ith one is less than or equal to n. Now I introduce the ITLs as logics in Hilbert style. For this, we need some toning language. A toning language is a counter-proportional language. I would like to say italic L with a tonicity map T-type, which maps every connective sharp of L n greater than 0 to its tonic types like this. Here, each SI is isotone, plus means the isotone, or antitone, minus means antitone. By this notation, we denote the application of sharp to n arguments, where underlined A is the sequence of arguments sharp except ith1 is ith1, and B is the ith argument itself. A tonoid language is called implicational if it has a connective arrow such that arrow is a binary connective and the tonic type is like this. This means that the first part, that is antecedent part, is antitone, and second part, that is consequent part, is isotone. First, I introduce the definition of implicative tonoid logics. Let italic L be an implication toning language, such that, like that, I already mentioned this one. And L be a logic in L, then we say that L is an implication tonoid logic if it satisfies the following. First, reflexivity and modus ponens, transitivity, and tonicity. As you can see, with respect to this connective, the first part says that the isotonicity, that is isotone, and the second part shows that the antisonicity for the each I less than or equal to n. Then I want to show that the simple example. As you can see, the implication, the consequent part of implication and the first and second parts of the intentional conjunction, they are all isotone. The antecedent part of implication and negation, they are antitone. So these two shows that each connective has its own tonicity. Then I would like to introduce weakly implicable logics introduced by Scintilla. We say that L is a weakly implicable logic if it satisfies reflexivity, modus ponens, transitivity, and congruence, like that. Then, using tonicity, I already said that using tonicity, we can show the congruence. So we can get the results like that. Implication tonoid logics are weakly implicable logics. The third section, that is algebraic semantics, more exactly matrix semantics. On the italic L matrix is a pair B that it consists of A, comma D, where A is an L algebra and D is a subset of A, called the elements of D designate elements of A. On A, evaluation is a function V, the set of formulas to the algebras satisfying like that. And given a matrix B is, we say that B evaluation. The validity and the model, the semanticons, those are the usual definitions. A formula A is valid in B if VA is a member of D for its B evaluation V. A B evaluation V is a B model of T if VA in D for each A in T. Let K be a class of L matrix. A is a symmetric consequence of T, denoted like that if mod T comma B is equal to mod T union the set of A comma B, they are equal. Then we say that symmetric consequence. From now on, let L be an implicational tonoid logic and B an L matrix. In particular, B is this one is a board-based L matrix if the logic L satisfies soundness. By mod L, we denote the class of board L matrices. We write the T Topton style A in place of T Topton style mod LA. First lemma, the relation less than or equal in B defined as A less than or equal to Y if and only if X LY in D is pre-order. Is symmetrization X equal to Y in B if and only if X less than or equal to Y and Y less than or equal to in B is a congruence on A. Then we need a Lindenbaum-Tarski matrix. Let blanket A indexed by T be the set of all formulas B such that T turnstile L A by implication B formulas T probably equal to A and L indexed by T the set of all the classes blanket A. The Lindenbaum-Tarski matrix L indexed by T with respect L and T is the L matrix whose designated set is like that, and whose L algebra has the domain LT and the operations like that. Then we can give a completeness. That is, if L be a theory over the implication tonoid logic L and A be a formula, then we can get this result. Note that the Leibniz congruence gives us the chance to provide the completeness with respect to the reduced models. Finally, we record this completeness very briefly. Define the Leibniz congruence omega indexed by generated by D of B as like that. There is some kind of equality relation, the pairs of satisfying equality relation. On L matrix, B is said to be reduced if omega blah is the equality relation. Then similarly, we can provide the strong completeness with respect to reduced models. Then Rutilmeier style semantics. in this section, we consider relational semantics called Rottenmeier style semantics, briefly RMS semantics for here finitary ITLs. For the technical reason, we need some kind of finitarity. For this, we need a labeled language. A labeled language is a tonic language italic L equipped with a labeled map L type, which maps every connective to its labeled type like that. Here, box represent connectives interpreted by universal sentences. Here, diamond represent the connectives interpreted by existential sentences. We use the three notations. The first one is, if we do not need to specify one of posing and non-posing, we use this notation. If we do not need to distinguish one of isotonicity and antitonicity, we use that notation. Using fork, if we do not need to one of membership and non-membership, we use this notation. Moreover, by R arrow, small a, comma b, semicolon d, we means that here there is some element C, that is an element D, such that R arrow A, B, C. Similarly, for R N sharp and N sharp, the underlined A semicolon D for an N connective sharp. We need the frames. Implicational tonoid are Rottenmeier frames, briefly TRM arrow frames, first defined. A TRM arrow frame is a 5 tuples where F less than or equal to relation is a partially ordered set, and R arrow and R sharp satisfying the conditions below. The first condition is related to partial orderedness, and the second postulate is related to the monotonicity. And we need for tonicity, we need the postulate, because the each analytic connective sharp that has some kind of labels, diamond, or box. Also, its ice argument can be isotone or antitone. The first postulate means that the tonicity of the analytic connective whose the label type is diamond and its ice argument is isotone. In this case, we give this kind of postulate. Similarly, we can give a postulate for the its ice argument is antitone. They are very similar, but only difference is here. Similarly, we can give these two kind of postulates for the box and plus and minus. Then we need evaluation. An evaluation of a TRM arrow frame is a forcing relation between the state of information and the proportional variables and arbitrary formula subject to the corresponding conditions below. For a proportional variable P, the atomic hereditary condition is hold, that is X less than or equal to Y, and X forces P implies Y forces P. For formulas A, B, here the condition for implication. The W forces A arrow B if and only if for XY in F, if R arrow XY semicolon W and X forces A, then Y forces B. As you can see, this one is interpreted by box, so it has some kind of universal sentence. That is, this one is interpreted by universal sentence. For the analytic connective, we need some kind of evaluation conditions. For diamond and its ice argument is an isotone, we need this kind of condition. As you can see, if its labeled type is diamond, that is interpreted by existential sentences. These two are different in this part. If the ith argument is isotone, then we give a y forces b. If the part is antitone, then y does not force b. If that is interpreted by box, then we give some kind of universal sentence interpretation. Here is ith argument is isotone. Because of that, we put the y forces b in the consequent part. If its ith argument is antitone, then we put this one in the antecedent part. Then models. The models and the semantic consequence and the bold-faced airplanes, these definitions are almost same in the algebraic models in section 3. So I do not want to introduce this again. We henceforth fix L, the italic L, as a labeled language and L as a finitary implicational tonoid logic in L. For soundness and completeness of L, we first note the fact that the for xy in A and D is a subset of A, x is equal to y, if and only if x Ly is a member of D. We introduce its corresponding postulate, this one above. Then using this postulate, we can provide the soundness like that. That is, if T turnstile A, then D top turnstile A. For soundness, we need the canonical frames. Canonical TRM arrow frames are defined like that. First, by an L theory, we mean a theory T closed under rules of L. Where T is an L theory, we define the canonical TRM arrow frame determined by T to be a structure F like that. Here C means the canonical. First, DC is the set of T, and FC is the set of L theories extending DC. Less than or equal to symbol C is subset relation restricted to FC, and RCs are defined as follows. First, the RC arrow. RC arrow A, B, semicolon C is defined like that. That is polar AB. If A arrow B is a member of C and A is a member of A, then B is a member of B. For analytic connective sharp in an ITL, we give some kind of 4 kinds of definitions RC. If there is a diamond, we have the whole sentence in the consequent part. If that is interpreted by box, then the whole sentence in the antecedent part. And the other is almost same in the postulate. That is the if its ith one is isotone, then B is a member of Y. But its ith argument is antitone, B is not a member of Y. And with respect to box case, if its ith argument is isotone, we put this one in the consequent part. And if that one is antitone, we put this one in the antecedent part. Then we can first show that the canonically defined TRM arrow frame is partially ordered. Moreover, we can show that the canonically defined structure F indeed the TRM arrow frame. For this, we proved the relation RC defined canonically above satisfied the postulate for the TRM arrow frame. So we can get this result. That is the canonically defined structure this one is a TRM arrow frame. Moreover, we need a canonical evaluation. This is a very user definition, canonical definition. That is A canonically forces A if and only if A is a member of X. Using this definition, we can show that the canonical evaluation lemma, that is forcing C is an evaluation. So using lemma 4.8, we can show that the strong completeness. That is, if the turnstile A, then we can get the turnstile A. Then I would like to introduce implication of partial Galois logics as some kind of specification or some kind of extension of implication tonoid logics. Similarly, we introduce the logics in input style. First, implicational partial Galois logics. L is said to be an implication of partial Galois logic if it is an implication tonoid logic satisfying any of the following. The first one is abstract Galois connection. The second one is dual one. And the third one is abstract Galois connection. And the first one is dual legitimate connection. We need some kind of tonicity. One, first, in each GC and DGC, the tonicity types of F and G are the same, and in particular, the tonicity type of their ice arguments is antitone. Second, in each RC and DRC, the tonicity type of F and G are different from each other in an argument distinct from I, and in particular, the tonicity type of their ice arguments is antitone. Actually, this definition is very complicated, so I want to show some example. I think this is very simple, and most guys can understand this example and tonicity. First one is a Galois connection. As you can see, this is a arrow, some kind of B, then we can get the equivalently B arrow, some kind of A. And it's dual one. This is an RC, C and A arrow B, then A arrow C, arrow B. This is a dual one. This complicated one is just means that just see this one. The tonicity, the red one and the black one, they are same. This part means that they are same. And in this case, RC case, this black part means that the argument place is different from the ice one. This red one means the ice argument. These two are different, and its ice argument is isotone. This means that those things. We further introduce implicational legislated partial Galois logic and implicational dual legislated partial Galois logic. First one is implicational legislated partial Galois logic. It is an implicational tonoid logic satisfying the legislation property, where the tonicity types of G and H are the same and the tonicity types of F and G. This is a very complicated. I do not want to read all this one. Just I want to explain the using by example. Similarly, we can give some definition of dual legislated partial Galois logic. This one, with this, where the tonicity, the dual legislation condition is this, and where the tonicity types of F and G and H are the same as in legislation. I briefly introduce using by simple example. This one is some kind of legislation condition, and that one is dual legislation condition. As you can see, these two implicational ones, the tonicity are the same. This tonicity and the tonicity, they are same. But when you compare these two, this part, the tonicity, they are different. this long introduction means those things. And semantics for more logics. Analogously, we can consider RMS semantics for implication partial Galois, blah, 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 logics introduced in section 2. Similarly, we need the frames. First, implication partial Galois Riemann frames, briefly PGRM arrow frames. A PGRM arrow frame is a TRM arrow frame where RF and RG satisfying this definition and any of these four postulates. Each one corresponds to the Galois connection, dual Galois connection, and residue connection, and dual residue connection. But the evaluation on a PGRM arrow frame is actually the same as that of a TRM arrow frame. So in this case, no interesting one. That is, as in section 4, one can prove the soundness and completeness of finitary implication partial Galois logics. So we drop this completeness and soundness cases. The interesting cases is residuated and dual-related ones. First, I introduced the implication residuated partial Galois Riemann frames, briefly RPG RML arrow frames. On RPG RML arrow frame is a TRM arrow frame, like that, where these three satisfy the definition and postulate below. This is the postulate for the residuation. And similarly, we can define dual residuated partial Galois Riemann frames. This one is the postulate for the dual residuation. For an evaluation on a RPG RM arrow frame, we further add the following conditions for sharp in the set of F and G H in a finitary implication residue partial Galois logic. For underline A, B, C, the analytic connect. For the analytic connectives, we need two conditions. The first one is the sharp interpreted. Its labeled type is diamond. Its i's argument is isotone, and its j's argument is isotone. In this case, similarly, we use these two forcing relations. If its i's one is if that one is interpreted box and its i's one is antitone, is j's one is isotone, then antitone part put the antecedent part and isotone part put the consequent part. As you can see, if this connective interpreted by diamond, that is gives us some kind of interpretation using by existential sentences. If that one is box, that gives us some kind of definition using by universal sentence. Similarly, we can give an evaluation on a DRM arrow, GRM arrow frames. In this case, if the J part is antitone, then we give this kind of definition, a condition. If box is i's argument is isotone, then we give this kind of condition. And dual ones, such as DRM arrow models, are defined as in section 4. Then, similarly, we can give a soundness like that. For the canonical frames, we need to define canonical D, RM, RPG, RM arrow frame. So we need these conditions. The first one and first one related the conditions for the canonical RPG RM airframe. The second and third one are conditions for the canonical TRPG RM airframes. The technique is very similar. If this one is diamond and plus, then we put like this. If this one is antitone, then we put the C does not member of, C is not a member G. If this one is box and plus, then we put like this. And if there is one is antitone, is this one is isotone, we put the antitone part, antitone part, and is isotone one, put the consequent part. As I already, C1 and 4 are for finitary implication related partial Galois logics, and C2 and 3 are for finitary implication dual related partial Galois logics. Then we can similarly give us some kind of canonical frames. That is, the canonical frames is partially ordered. Moreover, this one, the relation RC defined the canonical above satisfy the postulate for these frames. So we can get this result. That is, the canonical defined structure is a DRM arrow frame. Similarly, we can define canonical evaluation like that. Then we obtain the forcing C is an evaluation. Because of this, we can get the completeness. Okay, almost done. Concluding remarks, in this talk, we introduced implicational tonoid logics and the implicational partial Galois logics and provided routine style semantics. We still have some other problems in mind, which do not have the space to investigate in the present paper. For instance, we could introduce some expansions of the result in this paper, such as semi-lattice ordered, lattice orders, and distributive lattice orders, blah, 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 implicational tonoid and Galois logics. The introduction of the structures, implicational tonoids, implicational partial Galois, and the implicational dual-related partial Galois gives rise to the natural question about these structures in their own right, including their corresponding representations. But we leave this for another work. Actually, I give a presentation for some representation next Universal Logic conference. Thank you so much.
So if any audience has any question to ask?
I will just, meanwhile, people maybe are thinking about a question. I will just make some comments that, I mean, this this kind of work, of course, it's which as I think was developed with Michael Dunn, is something which is very specialized in some sense. So there was not so many people working in this field at the time, but of course it's a very important topic, and it's especially interesting from the point of view of the universal logic perspective to develop a general theory of logical systems. Here, of course, we have some specific system, but we have this general perspective. Mm-hmm. I was myself a good friend of Michael Dunn since many years, you know, and he came to Unilog several times and so on. So I was happy to have this talk today.
Yes, please. Jerry?
Yes, fascinating constructions you have accomplished within the language of logic and the RM logic particularly. The question that comes to my mind, if I accept all of these premises, which relate to the structures of the, shall we say, molecular sentences that you use, what happens to the concept of identity as you go through these structures? Can you preserve the concept of identity under these conditions?
Yeah, as you can see, we accept the reflexivity. I'm sorry, it's just I back to the page. Wait. Yeah,
Yes.
as you can see, it requires reflexivity. So this is just identity.
Well, it's identity, yes, I agree that in that usage in terms of Hilbert style, but it's not always the same definition in different mathematical structures. For example, the distinction between identity in category theory versus identity in group theory.
Oh, I don't exactly understand what do you want identity in logic.
But the question is, well, perhaps if it's clear in your mind, fine, you know, but I am very much a realist in my philosophical and scientific outlooks, and identity of any soma, any material body is part of the language that describes that body. And this is a bit more philosophical, I suppose, but the question of if you're going to apply this, these sorts of molecular sentences to atomic sentences, can you really make it useful in that context? Maybe that's too pragmatic a question. So I'll stop there if you have an answer. If not, it's fine. Thank you.
Yeah, I'm just a logician, just a pure logician. So I have no idea it's a real application. That is my another some kind of homework. Just my future. I need to study such kind of things, real application. But now I do not know exactly how to apply just such kind of things. I'm very sorry about that.
No, thank you very much. I appreciate your talk. It was very nicely done.
Oh, thank you so much.
So there's another question raised by the Jacques Rich. Eunsuk, do you like to answer that?
I got the one message.
Yes. Please.
Yeah, the minimal intuition. Yeah. The intuition is I would like to say this one. The related is as you can see, tonoid only requires process. In that sense, the structure is very simple. That means this is some kind of underlying structure. But one important thing is every connective requires some kind of tonic properties. That is, as I already introduced, as you can see, arrow has some kind of tonicity like that. Its consequent part is isotone and its antecipient is antitone. Similarly, intentional conjunction has both isotone. As you can see, the extensional conjunction and disjunction, those are things also both isotone. That means that as far as I know, every connective has its own tonicity, but tonicities we do not have much investigated such property. So I introduced the tonoid logics.
Okay.
Mhm.
So is there any other question? Okay, good.
Yes. My question is not, well, this entire thing is really research carried out in details, and it's in a sense fascinating material. And my question is about, it's a bit related to the person, Ms. Chandler, Jerry L.R. Chandler, just asked identity in a general sense. I would could you show me the page 6?
Page 6.
Page 6.
Okay.
Diagram.
Yeah.
Now, yeah, that's right. This, and my question is about this, how the other studies of implications would be related to some part of this picture.
Oh, yeah. Actually, all these
yeah.
kind of implications are some examples of implicational tonoid logics.
Yeah.
Yeah.
That's right. That's a group of people related to your research, and it's an interesting approach, of course. Now, linear implication and then Lambert calculus. Now, here's there's a professor Jui-Lin Lee. I noticed that you are you received a degree from Takeuchi.
Yes.
Now,
yes.
my question is also related to that, but in general, linear implication and Lambert calculus are studied from, well, logical point of view, but there are, you see, there's another approach in terms of quantale. Quantale is, definition of quantale is not difficult, but his origin of that idea, quantale algebra is coming from the foundation of the quantum mechanics, particularly C-star algebra. And then there's a British physicist, I think his family name is Malbay or Melbay something. And he studied the non-commutative or what is called in algebra, not associativity, but symmetricity. Algebra, non-commutative C-star algebra. That's the area. And he studied the ideals, left ideals and right ideals. And Malbay abstracted the quantale structure out of that study of non-commutative C-star algebra. Now, there's a short paper in the middle of 1980s, 86 probably. My memory may be wrong, but in the mid 80s. And there's a short paper written by him, Malbay, and he referred to Takeuchi's lecture notes or something, on linear foundation of quantum mechanics, as well as some kind of maybe some kind of logics related to the logical structure. Now, so what I would like to point out is, looking at this diagram, linear implication and Lambek calculus has sort of an empirical relations or philosophical connections different from the ones represented by the upper structure of this diagram. And so Michael Dunn and Lambek and some other researchers approach from one way. Of course, Lambek is again totally at the formal level, but Michael Dunn is algebraic. I've met both of them on different occasions. But now, what I would like to emphasize is linear implication and Lambek calculus, and then behind that, they are in a sense related to the foundation of quantum mechanics, quantum logic. Some part of the algebraic structures are related to quantum mechanics. Now, then let me just make a story a bit short. The philosophical question at this point, important one is the identity holds? Does the identity hold among quarks? How do you identity holds between two quarks? That's the question Michael Dummett, and yes, Michael Dummett asked at the end of a certain lecture given by, he visited from Cleveland, but now he is in Stanford, I think, philosophy department. He has moved. So since there was Professor Chandler asked identity with philosophical motivations or some, yes. Then I would also ask identity from the empirical quantum mechanics and quark, identity of quark. That must be one of the important way to look at this linear implication of Lambek calculus. Of course, I emphasize Lambek is totally formal, proof theoretic. And linear implication is a wide, huge area, and probably starting from a French logician. I couldn't remember his name, but the point is, he mentioned that French logician mentioned the quantum mechanics at least at the initial stage of his investigation. So to conclude, I would like to relate some the foundation of empirical sciences, particularly empirical mathematical sciences. That's a contradiction, but empirical sciences are very much related to linear implication or linear logic and Lambert calculus. Oh, let me just add some formal comment. Associativity is related to commutativity and associativity and distributivity are related to cut elimination. That's the end of my, I will finish my own comments. Sorry about that. That's all. And I really enjoyed the discussions and presentations, first of all. Yes, thank you.
Okay, thank you so much. I would like to things associated with your comments. First, actually, this kite is very related to substructural logics. Actually, we drop the associativity, we can get the logic GL introduced by Galois. That is the most basic substructural logic. That only requires some kind of identity in some different identity in some different meaning.
Could you repeat just what you said at the very end of your talk? Associativity?
Yeah, we can drop the associativity. There's the Galois called those systems GL.
Yeah, okay. The smallest Lambert. Is that what you mean?
No. Just actually, most guys, if you are a substructural logician, that we usually call the FL rather than the lambda calculus. That is the full lambda logic.
Yeah, but I do not take the substructural logic approach, and neither the approach of Ono.
Yeah.
But I'm familiar.
Yeah. Okay. So, but I'm sorry, I'm not familiar. Just quantum mechanics, such kind of things.
Okay. Yeah. Thank you for your comment. Yeah. Thank you for your reply. That's quite helpful. But I left this area about a decade ago, and now you see the interesting point. Probably some of you here may be interested in logic of coming from different tradition, and in particular, Indian logic. Now, let me ask then, is weakening, and I can point out where the prohibition of the use of weakening comes into which area. I can point out, but it's a sort of course, it's an interesting details come up. But I would ask, do you think? Imagine an ancient Indian scholar, and when he considers, say, let's call it A implies B, the meaning of implication is whatever can be taken as you like. A implies B, then without using any formal tools, just in terms of investigating the implication relation in terms of meanings, natural languages, then it is quite natural to assume, from my point of view, it is quite natural to assume that if there's no relation between A and B in the natural language, or whatever you think, you cannot imagine any relation, no relation between A and B, then you wouldn't say A implies B.
Yeah, right. That's the basic idea of relevant implication.
That's okay. That's good. Now, that is here the natural assumption is in ancient Indian logic, or if you like, Mimamsa school. But ancient Mimamsa is ancient, but not ancient, but in ancient Indian logics, or particularly Buddhist logic, then use of weakening was not available for those ancient logicians investigating implication relation in terms of meanings. Now, so it remains sort of a research question. That is, look through all the ancient Indian logics. Can you find any use of weakening in those texts? That's an interesting question.
That's a very interesting question, but actually I have no idea Indian logic. So that's the real problem.
Okay, then the next one. What is an Indian logic? And as far as Mimamsa, putting certain school of Indian logics, Mimamsa school. No, no, Mimamsa. No, not Mimamsa. The kind of logic studied by J.F. Stahl. And there's a dispute between J.F. Stahl and Nakamura, Hajime Nakamura. But the point is, J.F. Stahl used the logic of restricted variables. And that is, you can translate everything in restricted theory of restricted variables to typed lambda calculus. Therefore, one could assume that the formal structure of a certain school of ancient Indian logics can be interpreted by, represented by typed lambda calculus. Now, what is the semantics of typed lambda calculus? A topos, the category, a certain category which satisfies, say, a property related to exponential and all those other properties. That's topos, introduced by Lovea. But now there's a long discussions. What's the difference between bestimmt, definite set in the Cantor's sense, bestimmt, definite, Menge set, and Lovea's category theory. According to, if you look at the Lovea-Chanuel book, the one he is quite specific, clear. Everything is in their motions. And all those everything, the cows, mountains, houses, cows, mountains, all those are things in their motions. And that's again against the Kantian framework, of course. So then, as Professor Chandler mentioned, identity in category theory. How do, and one combining the Damet's comment question, how do you, is it possible to have an identity among things in their motions? Of course, in category theory, you can define identity only by using arrows, but those things would be philosophically more interesting, particularly the notion of God. God is a substance in Cantor, at least. But then in Buddhism, Buddhist tradition, God is empty and not substance at all. But then there's tremendous area of philosophy and lots of things in different traditions, cultures. There's one way to avoid those complications. That is the notion of infinity. Notion of infinity in set theory and the notion of infinity in, if you, some kind of Eastern religion or Buddhism particularly.
that's you can avoid so-called logical complications or complications arising from analytic tradition. Of course, I'm familiar with the analytic tradition, but if you focus on the notion of infinity in the East and the West in a broader sense, then you can avoid typical complicated arguments in analytic philosophy. Of course, I'm not against analytic philosophy. I'm quite familiar with that tradition, but there's a easy by focusing on the notion of infinity, you may be able to avoid unnecessary complications. But anyway, that's all I'd like to end. Thank you for listening. Anyway, yes, Professor. Who was?
So Jerry, would you like to say?
Yeah, my question, specifically question for you is, did you look at the Takeuti's short note referred to Melubei at the end of his paper?
No, I didn't. I actually work with him. It's about something related to the very weak system of parallel computing. So actually, the things you mentioned, I didn't familiar with that. And I didn't have a chance to take a look at those notes. Because when I stayed in the University of Illinois at Appalachian Base about 1991 till 1997, just right before he retired. Yeah, so I actually at that moment, he's working on the things called boundary arithmetics and in a weak sense. So I didn't really know that.
But anyway, again here I do not belong to. Well, yes, Takeuchi and Maihara are communicating quite often, and one of my teachers is Maihara. But I am not. I disagree on lots of points. I disagree with Takeuchi. He's always proof theoretic. Yes. Look at his textbook in set theory and the exposition of absoluteness. He used all X, attach that at the beginning of every formula referring to absoluteness. And that's because he used the system of ZF. And that's because of his proof theoretic inclination, but it should be used by set theory with class variables. But anyway, so it's quite all right that you do not look at Takeuchi's notes.
Yeah, it's unfortunate. I didn't have a chance.
But then that's one of the documents I'm looking for. And he wrote books, papers in Japanese on quantum logic or foundation of quantum mechanics. But I've never seen. I was unable to find Takeuchi's notes referred to by Melubei. So if you happen to have a chance to find it, just let me know. That's all.
Okay. I hope so, but I'm pretty unsure about that. Yeah. So Jerry, do you like to ask some questions, because I see you have raising here? Yes.
Yes. First of all, thank you, Professor Koji, for the insightful remarks. You identified quite precisely the basis of my concerns, the logics involved in this context. I would ask if the question of quantum particles, the question of opposingly charged quantum particles, is the basis of this argument in the sense that can this be extended, generally speaking, to other bodies, other soma, that is from atomic sentences to molecular sentences? Is this a general concern about the relationships of logics of charged particles as opposed to points? So that's the basis of my concerns. And I thank you very much for your very excellent summary of a wide range of concerns. Thank you.
Oh, that's my pleasure. That's my pleasure. Probably, though, if some of you are interested in linguistic approach, I would like to point out that a atomic sentence, usually in a standard predicate logic, atomic sentence consists of the subject, object, and then you have a copula connection. Like typical sentence would be Socrates is, I would say wise, or Socrates is good. Now, immediately, a question coming up from that. What is good? What is good is an entity substance. You cannot locate what is good within the time space structure. It's not, you cannot point out the position of what is good in time and space. But then if you look at language, which does not have the basic structure of subject-object combination, now you notice that noun phrase or uncountable nouns, or simply just simple plural, like cats on the mat, that's another candidate to approach the, let me use the things in the emotions, linguistic expressions corresponding to things in the emotions, maybe uncountable nouns or simple plurals like cats or cows, houses, even mountains. And then by probably those familiar with the linguistic analysis, you can start your own investigation. But then let me point out this one thing, that is, when you look at the Indian texts, particularly a certain Sanskrit text about the one of the foundations of Mahayana Buddhism, not Theravada, Mahayana Buddhism, that is developed in China in later years. Well, but that's still ancient. Now, infinity, in set theory, the crucial point of infinity is, now let me change to a Cantor view. Then you start with in today's word, large infinities. And the smallest one is weakly inaccessible. And the next one, well, next group would be strongly inaccessible cardinals. And then goes up weakly compact, and then measurable, and more. Now, Termello introduced the notion of strongly inaccessible cardinals, and he called it Grenzzahlen. Grenz is a border between mathematical infinity and theological infinity, but things created by God. That probably one interpretation is natural thing, natural or physical things. And then above that, the infinity represented by angels. And then finally, the infinity represented by God. That's the structure of Cantor. But then Cermelo restricted it to so-called Cantor universe up to Grenzahlen. So Grenzahlen is the point is that this divide the world of into the world of science or mathematics and the world of theology. That's a bit clear in Cermelo's 1931 paper. Now, yeah, that's right. Was it 31? Probably so. The same year as Gödel's incompleteness. Now, look at the Indian side. What comes in between infinite large numbers and then not large finite numbers, but infinity.
Okay.
And ancient Indians have developed all those large finite numbers. They have introduced interesting classifications and so on. But that's done, all done. And then once going to the infinity, those Indian scholars, ancient scholars use metaphors, rain, clouds, and mountains, and ocean. And the interesting question here is, are they abstract simple plurals or uncountable nouns? Of course, they use the sea. And so that's Sanskrit as a language has a detailed structure. Now, so you can find mountains are used in plural or in which form. And the same question goes to seas, rains, and so on. I haven't done those things yet, but and again, there's a Chinese tradition in China.
Okay.
Chinese character is totally, well, not. Of course, it's possible to express plurals, but usually a single Chinese character, for instance, corresponding to goodness or what is good, then you're already in trouble. One Chinese character representing good, it does not refer to abstract things or similar to what is good or goodness. No, Chinese character representing goodness, or in Japanese it's pronounced Zen. Probably denote or designate things in their motions, not things in themselves, or not abstract entities.
So,
and one thing is relation. That's one answer. But anyway,
okay.
Sorry for that.
That's all right. So, Koji, but I think we are really running out of time. I think the discussion is interesting. So maybe we should extend that some other place. So I'd like to thank all the attendants here, and also thank our two speakers and for their efficient presentation. Okay. So John, maybe we should end our session today now.
Thank you very much to everybody. It was very nice. The next session, I put it on the chat, will be April 13. And meanwhile, we will have the Unilog. So Eunsuk will come to Unilog. So we are very glad to see him on location. Thank you very much, Jan, and we'll see you next month.
Okay, thank you so much.
Thank you all.
So thank all of you. Yes.
Bye bye.
Bye bye.